Physics part 16. The smallest deviation on the meter rule is 1 millimeter. If you take the precaution to avoid parallax error, you should be able to estimate the reading to about 0.5 mm. If you are measuring the length of an object by taking a reading at each end, the uncertainties add to give a total uncertainty of 1 millimeter. The range of the meter rule is from 1 millimeter to 1000 millimeter. To measure a length of more than 1 meter with a meter rule will introduce a further uncertainty of perhaps 1 millimeter or 2 millimeter because of the difficulty of making reference mark at the 1 millimeter end of the rule and moving the rule as that the zero exactly correspond with this reference. It is usually better to use steel tapes to measure lengths of more than 1 millimeter or more than 1 meter. I beg your pardon, please. The micrometer screw gauge, the type of the micrometer screw gauge available in a school or college laboratory, may be used to measure the dimensions of the objects up to a maximum of about 50 millimeters. Measurements can easily be made with an uncertainty of 12 cm, 12 um, or less than that. The principle of instrument is the magnification of linear motion using the circular motion of a screw. The instrument consists of a U-shaped piece of steel with a fixed plane and piece. As you can see it in the figure, opposite this is a screw with a corresponding end piece B. The position of the screw can be adjusted using the ratchet C, which is connected to the thimble D. It is connected to thimble D. There are graduations along the barrel of the instrument, the bearing in which screw turns, and the round, the circumference of the thimble. The purpose of the ratchet is to ensure that the same torque, that is amount of the twist, is applied to the thimble for each reading. If this torque is exceeded, the ratchet slips. The object to be measured is placed in the jaws of the gauge between the end pieces A and B is screwed down onto the object using the ratchet C until the ratchet slips. The screw advances exactly 1 millimeter for 2 revolutions, that is the pitch of the screw, which is 0.5 meter and 500 If you look at the graduation of the barrel of the screw bearing, you will see that there are deviations every 0.5 millimeter. The reading on the barrel corresponds to the position of the edge of the thimble. Reading on the barrel corresponds, as you can see it in the figure. The edge of the barrel is in its own position. The graduation round of the millimeter of the edge barrel is in. The graduations round the circumference of the thimble run from 0 to 50. Each deviation corresponds to 1/100th of a millimeter or 10 um. The reading on the thimble is added to the 1/100th of a millimeter or 10 um. The reading on the thimble is added to the reading on the barrel. Thus, figure shows a reading of 9.5 mm on the reading on the barrel. And thus, the figure shows a reading of 9.5 millimeter barrel plus 0.360 meter for the thimble, 9.860 millimeter in total. You can easily read to the nearest division on the thimble, that is to the nearest 0.01 millimeter, that is 10 um. Well, the figure of the micrometer screw gauge. Then another figure, screw gauge scales with a reading of 9.86, another one from 10 to 15, then another one from 14 to 45. The figure shows a zero error of plus 0.12 mm, B0 error of minus 0.08.